Okay, so we're talking today about definite integrals and antiderivatives. This symbol means the integral. What does that mean? Effectively, the area under the curve from A to B, and we'll call A the lower bound, B the upper bound, of some function of x, and there always has to be this dx. Okay, remember when we do derivatives, we'd get, say we had this, we'd do the derivative, we'd get dy dx equals 2x. Well, I could think of this. Dx just stands for derivative of x. Why am I doing that? That's not what I want. I want to change the color. I could think of this as dy equals 2x dx. When you divide both sides by x, you end up with, or by dx, you end up with that. Okay. So when I integrate, I have to have my dx. And what does this tell me? Eventually, if you have to take Calc 3, you'll have multiple variables, and your D tells you which one is the independent variable. And you'll end up doing something called triple integrals, where you'll integrate the x once, and you hold y and z constant. Then you'll integrate the y. You'll hold x and z constant. Okay, and then you'd integrate the z, hold x and y constant. So this is a very important thing. You can't integrate without it. Okay, now we're going to talk about our rules of integration. And this is basically how do I, what things apply? Or what are some general rules? So here I am switching the bounds, putting my bounds backwards. That's exactly the same as the regular integral except negative. Okay. Um, Something you should have learned from yesterday's video. If the integral if the function is below the axis, the integral here is actually a negative value. It's equal to it's negative the area under the curve. So this is rule one. That's not so hard, is it? Rule two is also not very hard. The area from A to A, meaning it has zero width, is zero. If the bounds are the same, the integral is zero. The area is zero. That makes sense? This one is going to be pretty useful, mostly just because it makes our life a little easier. If we multiply the function by a constant k, and if you look in the book, they'll show it with a negative 2, which I would just say a negative is the same as a constant, so I'm not going to write it twice. We can pull that constant in front of the integral. We can do the whole integral and multiply by the constant after. Rule 4 is highly useful, which remember how we took derivatives term by term? It says as long as the functions are added together, the key is adding here, you can integrate them separately.
No subtraction.
It works with subtraction too. Plus or minus, but does not work with multiplication, just like you had to use product rule when you multiplied. No, wait, before I move this up. Rule 5. This one's a little interesting, but it mostly makes sense. The integral from a to b so if I go a to b and then b to c, that's the same as just going a to c. And you can go, equal signs work both ways, right? So sometimes you'll have this a to c and you'll want to split it up. This one is a very interesting, and I will draw you a picture. So keep in mind that the integral is the area under the curve, correct? So we're going to say this is a to b. The minimum f is here. The minimum f times b minus a is this area. Clearly that's less than the area under the curve, isn't it? So that means I take the minimum value of the function on that interval and then multiply it by the width of the interval, b minus a. The maximum, I take the largest value on the interval and multiply it by b minus a, so that's all of this area. And I can tell you that the integral, the area under the original curve, is between those two, isn't it? Does that make sense? The last one is also kind of a little bit of an interesting rule. It's called domination. If f of x is greater than g of x on the interval a to b, then the integral of f of x is also going to be greater than the integral of g of x. And this applies whether this is f of x is positive or negative because f of x would be less negative, so it's still greater. Or the integral would be less negative. Okay, so now we're going to apply these rules. And to do so, we need to be given a few things. And just a hint, your quiz tomorrow has a couple questions like this. So it tells us this information. Does not tell us what the function is, but it gives us these pieces of information. And then the question is, what's this one? Yeah, it's this one switch to the bounds, so I negate it. So it was -2, so it's -2.
Maybe for the transactions shown.
A and B are my questions.
Okay.
These are my three statements. Three, yeah. 5 plus -2. I'm going to use brackets instead of double parentheses. So the bounds are -1 to 1.
So we can put those constants out.
No, because they're not the same. If I wanted to do it individually, I could, but so I could do this like this, which is, I guess, essentially what I'm doing. I just don't usually notate it. Yeah. So it's 2 times 5 plus 3 times 7.
That's
Okay. I'm going to erase a bunch so that I have room for the next three, because you probably still need to see the top stuff.
already into room. The math.
I'm not sure that they are. They're pretty intuitive. There's like, especially the first four are the ones that we really use. Um, what about D? I'm going to write the next one. What do you think about this? You cannot do this
Awesome.
because you can't just divide that in half and assume it was symmetric.
Huh.
What about this one? Yep. And a. What about this last one?
So,
Yeah, you have enough information to do the f of x part, but not the h of x part. I mean, you have to figure out that it's not.
I'm saying,
No, I'll probably mostly give you ones that you can solve. Um, okay, next one says show that this is less than 3/2. So this involves my max thing. What is the maximum value you can ever get for cosine? 1. And that would be at 0, so that is in that interval. 2 times the interval, which is just square root of 2, which is definitely less than 3/2. That makes sense? Now, something useful. You need to make sure you know this. And this is going to show up again the first day after break in that lesson. The average value of a function. So keep in mind that this integral part gives me the area, right? That makes sense. The integral gives me the area. And area, if it's a rectangle, it's just length times width, right? Well, your width here is b minus a. So I'm dividing by my width, means essentially I've got average, essentially height of the function divided by width. So this is the area divided by the width, that gives me the average height, or the average y coordinate. So now applying this. It says find the average value of the function for this function on the interval 0 to 3. So that is 1 over 3 minus 0 times the integral from 0 to 3, 4 minus x squared dx. Well, we haven't learned how to do that by hand. That comes for the week after break. So we're going to do that by calculator. So 1 divided by 3 times, because it was 1 over 3 minus 0, 1 divided by 3. Menu, calculus, numerical integral. It automatically fills my, and then I have to make this a dx. I do have to tell it which variable to integrate for. Hey, that's 1. Does my function ever take its average value? Yes. If I think about my graph, so I plugged this into the calculator. I guess I probably didn't show that in the video, but that's fine. It's 1. If I think about my graph, 4 minus x squared is a parabola opening down. It crosses here at 2, 0. So it definitely takes on the average value. That should generally be the case. Um, there was an if condition to this, that if the function is integrable. So you'd need the same ideas as differentiable. It's got to be continuous. It can't have sharp corners, etc., etc. And final example. Finding an integral using antiderivatives. Okay. This is an intro to next week. Finding an integral by reversing derivatives. So the integral from 0 to pi of sine of x dx. Well, what would give me what would of the derivative of what would be sine x? Negative cosine x. And how you notate this is from pi to 0. So I do negative cosine of pi minus negative cosine of 0. So after you take the integral, you use this bracket, you put the upper and lower bounds still on. And then you plug in the upper bound minus the lower bound plugged in. Negative cosine of pi is negative negative 1. Minus negative becomes a plus. Cosine of 0 is 1. This is 2. That wasn't so bad, was it?
Is this part of other test?
I don't think I'm making you do one of these on the quiz. It'll be on your next test, which I think is 2 weeks after break. I think you have a quiz. Okay, that's it.